Alright, hi, this is PwnySec. Today we're going to be covering HTTP smuggling, which is made popular, and there's a couple reports found by, I didn't prepare any. What's his name? He's the creator of. Darn it, and he's on my follow list. Anyways, he's on HackerOne. Anyways, so what is HTTP smuggling? So, there's a layer of, like, the HTTP protocol that, like, we don't commonly see because we interact with it through burp. But, web request will... Yeah, so there's about 3 different ways this will work, but for this demonstration, we're just going to cover one of the ways. So there's transfer and chunk coding. So it reads this length, 43, as the total sending packet right here. This part, because the front end reads the content length and the transfer encoding, and it in the back end does the same thing, I believe. So it reads the 0 as another content length, and it says 0, and that starts a whole new request. So you can see in this demo, right, the content length is, and this isn't true for all of them, there are different ways, so just kind of keep that in mind. But in this example, we have the content length, which is this whole thing, and then it does chunked encoding. So with chunked encoding, it's telling the server or the thing handling it that this is the start of a new request, and then it will read this part on after it's gone through, because there's layers to the how the requests go, and it's pretty cool. So it's almost like magic. So it'll read the first part as a request, this part, and then it'll send it over right here, and you see the front end reads this, and then this part gets submitted beyond the front end to the back end. So this part's read as a valid request and sent on, and it doesn't read this part next. It just assumes, because the first one's approved, that the next one's approved, because usually in web, these the front ends, I want to say it's one of the culprits is a load balancer, and how the requests get prioritized and stacked up in the in red. So we're gonna need this booger for later. The most HTTP request smuggling vulnerabilities arise because HTTP specifications provides 2 different ways to specify where a request ends: the content length header and the transfer encoding header. The content length header is straightforward. It specifies the length of the message body in bytes. Yeah. So the first part of this is it's reading the content length, and it's not filtering the content length. So the front end can also expect a certain content length, and it can reject other content lengths that don't match it. So that part can be really tricky. But this is kind of like the front end. So there's more trickier ways, and we'll see that, like, you have to play around with this quite a bit. And what is B? B right here is hex. So that it isn't arbitrary. It has a specific meaning. So in B, and hex is 12. I want to say it's 12 or 11. 10. A is 10, so it's 11. Yep. I'm a genius. I had to look that up. So anyways, so that part can be tricky, and then but you don't have to use hex. Sometimes you do, sometimes you don't. It depends. You can use the numbers, but that can also be tricky because the number lengths. I think it can only handle so many. It's tricky. I'm just gonna say that. I'm not 100% sure. I'm not sure why it needs to be in hexadecimal. Let's see. The header can be used to specify that the message body uses chunked encoding. This means that the message body contains one or more chunked data. Each chunked data consists of a chunk size. I guess it's because how it reads the chunked encoding, it has to be in hex. Expressed in hexadecimal. Because I tried using decimal earlier and I didn't get the results I wanted because it produced decimal when I used the application. So there's some demos we're gonna be doing in a minute. Yeah, and this is what are unaware of this for 2 reasons. Burps, because a lot of us use burps, so we don't actually see this, and that's why I think this is so freaking cool, is because nobody sees this, and it's it really works, and it's like you can cause the page to break essentially, and then the burp, and one way to tell if the site is vulnerable is it will hang. So the burp request will hang, and it'll only and the burp request will only go through when the next valid web request hits. And I thought that was really creepy. So you can essentially poison a web request socket. So the back end, they especially with the containerized environments and all that, they it proxies, and it does all this magic behind the scenes to get the web request to the right container, and you can really, really screw with it, and it's really cool. Yeah. So and there's 3 ways to do this. So there's content length, transfer encoding, where the back end is expecting uses the content length header, and then the back end takes the transfer encoding. Then there's transfer encoding in CL, where the front end takes the transfer encoding and the back end server uses the content length header. And that's why this can be a little bit tricky, and you start using hex. and then there's transfer encoding, where they both support transfer encoding, and that's cool. I think that's really cool. So I'm elated to kind of like understand this more and go try this vulnerability out in the wild, because with the modern environments, they seem like they're susceptible, and I've been playing with a few websites, and very interesting. So anyways, it's very cool. So let's explain the basics here, right? I like these simple examples. So we have the post. You can use it images. So we have this part, and one reason this vulnerability arises is because of HTTP 1.1 the new one 2.2 or 2.1 support solves this vulnerability, and it properly handles the web request and breaks it. So this one, the front end supports the content length. The content length is the total, and that includes the smuggled. So, and you got to count the empty spaces. It's, I believe, 2 bytes. Right, and you got smuggled, and it goes up to smuggled. So that's right here, 5 bytes up to smuggled, and then smuggled's 8. So 5, 8, yeah, so 13. So that works. So we're gonna do this one, and this one's is darn tricky. I promise. I think I have my notes up. Excuse me. this is what we're gonna do to solve it, right? You got to get the G to read the next request because it's expecting a post request. So when we send the next request, we're gonna send it twice because yeah, and we'll see that it truncates the G onto the post, and we get a G post. So let's access the lab. Oh, and CAPTCHA's a evil. So in the wild, just Google it. The HTTP smuggling video, and the creator of this made a video. You might watch that at the end actually, because it was really good. Yeah, we'll watch it at the end. And he kind of goes through it, but he uses this part of it, and he doesn't use repeater because CAPTCHA gets in the way, and you have to solve it to submit a request, and yeah. And there's ways to automate CAPTCHA out of the equation, but I don't want to do that. I feel like that's illegal. Not really. I don't know. But they have this really cool tool. It takes it solves CAPTCHA by using the voice option, then sending the MP3 file over to Google Translate, and Google Translate reads the MP3 file and converts it into text, and then it enters the text into the CAPTCHA to solve it. Pretty darn cool. And I think there's also a BERT plugin that requires customization, and it's not very easy to use out of the box, but it's good. But you have to fix it. Did we send it to repeater? Yeah. So let's go over to Repeater, and then we're going to turn this into right-click, change request method to post. This is to the PortSwigger website. Let's redo the video. I'll just stop it. Yeah, I'll just stop it. I have to stop it. But alrighty. So a big giveaway that the site is at least vulnerable is HTTP 1.1. Okay, so that's something kind of to when you're trying to find sites that might be potentially vulnerable. And a lot of people just don't want to don't want to upgrade and don't want to patch, and they think because I think they have too much faith in their passwords, and they can user control within like mechanisms. Okay, and yeah. Anyway, so we're gonna change this to post. Content length matters, and up here in repeater. For the initial one, this doesn't matter, but this matters later, and it fixes it always when I update that. So, if you remembered, we want to do transfer encoding chunk, right? And then we want to do a 0, and then we want to do we're gonna use this. There we go. I'm just getting a little OCD. Smuggle. Oh, that's not what we wanted to do. So we want to do, because it's only accepting, if we go back to the lab notes, we have to make a G post, and it won't solve it until we do a G post. So you might solve it, but you didn't solve it. My back's screwed. Anyway, let's do a G post. /http /1.1. Then we'll do host. And this is pretty cool. So one part of the web request, you can't have duplicate headers. So one way to get around that and still have it read it is to use lower caps, and you can do all kinds of things to obfuscate the headers so that they're red, but they bypass the filters, but they're still red literally, even though they're obfuscated. So that's pretty neat. vulnerablewebsite.com content length. And then we'll just do ponies rock. And you have to have a break right there. And if you don't have that break right there, it continues reading it. So I think this should work. We have to send the request twice. So for the first one, it's really tricky. So we got G post, invalid request. There we go. And see, you notice these little things, like it, you remove that space, right? And it doesn't work. Right, but we add that space. We see the valid request, and now it's poisoned. So the next time the request goes through, it's gonna hit. It hits the G post, and let's just see how creepy this is. Okay, so we're gonna send the first valid request, right? All right, and the second request hitting the website's ours, so it should redirect. What the hell's G post? Isn't that cool? That is really cool. That is really cool. And there's so let's do the next one, which is where the front end checks for the transfer encoding, and the back end uses the content length. So this one inverts it essentially. So we predefine the content length in the first request, right? And then the next set of numbers, and these can be in hex or decimal, and there are issues with decimal, and I'd recommend with larger requests to use decimal, to use hex. Or maybe they've always used hex. That's also maybe 114 in hex is different in decimal. My brain hurts. Anyways, so let's go solve this one. Doom 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 doom. And to solve this, so you don't get in a rabbit hole, you must submit a G post. And I went over it. Having these is nice. Alright, so let's capture our web request. And then we're going to convert this in. We're not going to send this. We're not going to convert it. And sometimes it's better to drop it. So don't always do that. So like if we're doing a reCAPTCHA, at least I don't think it matters, but if you're doing reCAPTCHA, drop it. Or I want to say drop it. Maybe hold on to it. I'm not sure, but I've had problems getting around to reCAPTCHA, and it's such a so we're going to convert the web request, change it, so we get the content link and some other stuff. Okay, so then this one, the content length matters, so we're going to set the content length to we're not sure yet. So then we're going to do chunk transfer encoding chunk. And I don't think it's obfuscated on this one. So then we will use the tool to solve this one. So we're going to use the same thing as we did last time, but we're going to type it out again because it's good muscle memory. I want a bigger screen. Right, so post HTTP example.com content link colon. We're going with 4 on this one because we're not doing smuggled. So there's going to be 2 spaces, wait, 1 space, and then we're going to use 2 hexadecimal numbers to, yeah, because I think we're going to try to hit around 90 bytes. But we'll use the tool, we'll do it manually and then try to do the tool once I get frustrated and I don't use the tool anymore. Ponies. Rock. 0. And the 0 is saying the next content length is 0, and it'll stop reading the request. So you could stack up requests, and then use 0, multiple zeros, I believe, to do like terminate different things, and because I've been trying to read the bug bounties that the guy who, I wish I knew his name. That didn't suck. But I've been reading his bug bounties. So what's a good way to read the bytes? Sure. So let's put in a file. Shift colon set pace, hit the insert key, and then Shift V. There are 63 bytes. And So this website over here, this thing, like you could find it. I doubt they have it done now. And we running any slower, I think we could. So 63 to hex. Oh. Well, let's just try 63. Transfer. Oh. Yeah. Let's change this to 4. Oh, it's a valid request. Fine. Let's use that thingy. What is this called? Wish I knew. Tight. Maybe it's base 64. Oh, my ADD kicked in. Sorry. Yeah, Yay! Something I like invalid request. That is A-okay. I wish there was a way to get the... Oh, so that's what that's... Oh, okay. $63. Okay, cool. So F3 63. Let's just make sure it's right. Pony Rock. Yeah. We can set this higher. Maybe that's why. Oh yeah, that's probably why. 4, 2. Let's also try a space. So the reason why we doing that is because the front end accepts the transfer encoding, and then the back end deals with the content link. So the front is valid 2, 4, and then it should truncate here. Maybe the zero's in the wrong place. Let's try giving it a little bit more space. That's what my notes say. And this is the PECE. Oh, I had a lot of complaints about this one. It is tricky. So, So we got the post. 3 is the content length, and it reads. Maybe these are 1 byte. And then it reads smuggled as next valid request. Transfer encoding chunk. See the solution. What did I do wrong? See, it's so picky. Ooh. Oh, maybe it's the content type I messed up. I doubt it. Alright, see, somehow I befuddled it. So we're just going to use the Burp tool. 7663. Let's try go to Pony Rock. But it'll do 63 decimal instead of no. That's 7B. Yeah. I'm gonna confuse myself the other day. $7 dude. 123 bytes. But I did add some extra stuff to it. This should work. Oh. We're trying with the 2 length. Bam, bam, bam. There's something invisible here. Alright, so something. There's more to the request. So we're gonna go copy this. Yeah. Then we'll do Pony Rock. We'll play. We won't do that either. Then we'll grab this. And then we'll convert to chunked. We'll turn this to 4. And it should work. Oh. Oh. Unrecognized Y post. Y equals. That's cool. But if we put in rock 0. Oh, so it's reading rock 0 on top of a post request? That's even cooler. So, but if we put a G. The G will change the content link. And my session expired. Alright, I'm back. God. I just want to show people things, okay? I don't see why this has to be so difficult. Now we're gonna right click, change the request method. Notice the content link that appears. Alright, and then we'll paste in that stuff. And then damn it, that tool actually does a lot more. Isn't that pretty neat? But this will be a valid request and it'll truncate the XE part, so I don't think I want the G in there, but let's just add the G. Let's do so this is, I believe, where we poisoned the request. So we send a request through, and once that lands, it gets the readout error. So that's pretty cool in itself. And I think this error is occurring because it's maybe it is decimal. Oh, I know why the error that we got that weird error the last time is because it was reading this content length, and then it truncated, I believe, like part of it. Oh, so let's try 15.00. And you know what? I don't think we want to keep post. That's gonna mess up like the content length that it's expecting. Valid request is good. So now we poison the socket. And once the page lands, let me see that. So let's look at the solution here. And there's 2 spaces. So let's just copy this and then delete. And we'll enter the value 2. No, what the? Whoa. That's pretty cool. A bike. I haven't had this happen before. But notice we really fucked up the webpage. Let's see what. What the fuck? This is cool. Whoa, we totally broke it. You know what? I should have been careful. What? And this is what I'm kind of talking about, like the weird nature of this. And how, like, badly you could really... Maybe it's pulling in an image somehow based off the X. Cool. But this isn't what we wanted, is it? There we go. Unrecognized method G post. That was really weird. That was very weird behavior. I did. Hope I didn't break anything. But this should be for my own little special instance. See, and I didn't break anything. It only temporarily. I want to say temporarily, like hijacks it. We got one more to go, so we're almost there. And this one's gonna be obfuscating. This is so tricky. You guys see what I'm talking about? This is the little thing, like the littlest thing, will mess this up, and it's very hard to test, and it's not easy. It's been quite a while being looking for little details.